Hi everybody, welcome to Unicore's product release program. In this video, I'm going to introduce our new generation GNSS module, UM982. UM982 is a high-precision dual antenna module with RTK technology. It's worth noting that both of the antennas can perform high-precision RTK positioning. Besides, the use of two antennas makes the module capable of doing high-precision heading solution, which is another distinctive feature of this module. Before talking about the module, let's have a look at the chip. Remember the theme of this presentation? That is, Nebulas-IV inside, the best forever. So Nebulas-IV is our new generation GNSS chip inside the UM982 module. It's the fourth generation of our Nebulas series chips and is superior in many aspects. It's processed with 22 nanometer technology and has integrated radio frequency, baseband, and high precision algorithm on a single chip. This chip has three main features. First of all, it's small, with the size of 7mm times 7mm. Secondly, it's powerful, with 1,408 channels concurrently tracking satellite signals from multiple constellations and multiple frequencies. Last but not least, it features low power consumption. Compared to our last generation GNSS chips, the power consumption of Nebulas-IV has been reduced by 5 times. Based on the Nebulas-IV chip, UM982 module also has the aforementioned features. It can receive signals from GPS, BDS, GLONASS, Galileo, and QZSS, supporting multiple frequencies with low power consumption and high performance. Besides, it also features ultra small size, high precision with two antennas, and can output RTK positioning and heading solution. This module is especially designed for applications such as UAV, precision agriculture, autonomous machine, etc. Just now we mentioned the small size of UM982, and in order to give you a visual impression, here is a group of pictures. On the left is a British £1 coin, of which the diameter is 23 millimeters. The second one is our UM982 module, whose length is 21 millimeters. The third one is a US 1 cent coin, and the last one is our previous generation GNSS module, UM982. So we can see that the new module is about the size of a coin, and compared to our last generation product, its length and width have been reduced by half, which means that the area on PCB has been reduced by 72%. Apart from the size, you may also discover that the appearance of the module is different from the old one. Yes, we choose stainless steel to produce the shielding shell and have the product information printed with laser engraving instead of labels. In this way, it facilitates heat dissipation and can prevent corrosion. Moreover, the bottom of the module uses electrolysis nickel immersion gold, or ENIG, process to improve the solubility of copper contacts and plated through holes. As mentioned before, the Nebulas-IV chip is highly integrated and it supports dual antenna input. This slide shows the block diagram of the module. After the signals are received by both antennas, they will pass through the LNAs and SAW filters and then enter the Nebulas-IV SOC, which finally outputs heading solution for users. UM982 features dual antenna heading. It can provide high-precision heading results, no matter in static or dynamic scenarios, and the heading accuracy can reach 0.1 degrees at 1 meter baseline. Another unique feature of UM982 is that it supports more frequencies. Different from most of the GNSS modules on the market, which provide dual frequency solution, UM982 supports tri-frequencies, that is, L1, L2, and L5. And in this slide, you can see the frequency bands in satellite systems supported by the master antenna and slave antenna of UM982 module. The tri-band solution can greatly improve the RTK fixed rate and positioning accuracy. As shown in this table, the RTK fixed rate with tri-band can be improved to 83.26%, and the heading fixed rate has reached 88.12% in urban canyons. There are other advantages of the tri-band solution. First, it can speed up the RTK initialization time and reduce it to less than 5 seconds. Second, it provides higher RTK fixed rate, higher accuracy and reliability in complex environment. Third, the module can adapt to various data services since it supports more frequencies. Fourth, it's compatible with different combinations of GNSS signals. Last but not least, the tri-band solution can provide more observations, which mitigate ionosphere interference and help to eliminate errors. Next, I'll introduce some of our key technologies that improve the positioning results. The first one is called dual RTK technology. This technology enables the module to output two independent solutions using both the master antenna and slave antenna. And in this way, the control platform is able to compare the two results and make judgments, which improves the reliability of RTK positioning. Another advantage of the dual RTK technology is that when GNSS signals are obstructed by some objects, if one antenna cannot receive signals, the other one can still be utilized to output accurate positioning results. Another common problem in satellite positioning is that data service might be interrupted. As we know, high-precision navigation needs differential correction data sent from the reference station to improve its accuracy. But in real applications, data transmission is usually interrupted by the environment, such as mountains, or there are some areas where 4G and 5G communication cannot cover. And if signals are interrupted, the RTK positioning accuracy will drop fast and cannot reach centimeter level after about 20 seconds. In order to deal with this problem, Unicore has developed RTK Keep technology. This technology uses models and parameters to eliminate the satellite orbital errors, clock bias, ionospheric and tropospheric errors, etc. It can keep centimeter level positioning accuracy for more than 10 minutes after losing the differential corrections. And this makes UM982 well suited for the applications such as UAVs and forestry operations. While UM982 features high performance, its power consumption maintains at a low level. Compared to our last generation GNSS module UM482, the power consumption of the new module has been reduced by 70% and is less than 600 milliwatts. With low power consumption comes less heat, which is another advantage of this module. In real applications, a module is usually placed in a closed machine where the temperature could reach dozens of degrees when working under the sun in summer, and users need to do a lot of design to enhance heat dissipation. This picture shows the temperature of UM982 after operating for 1 hour at room temperature, and we can see that the highest temperature is only 38.2 Celsius degrees. Next is the high sensitivity design. This design aims to solve the problem in mass market where the application scenarios are complex and various, and often characterized by weak signals. In such harsh environments, sometimes we can't get a good RTK fixed result, and under that condition, a reliable single-point positioning solution is necessary. With Unicore's high sensitivity design, the tracking sensitivity can be improved to minus 163 decibel milliwatts, and the acquisition sensitivity improved to minus 147 decibel milliwatts, and the single point positioning fixed rate maintains more than 99.9%, even in the most challenging environments, as shown in the picture where high-rise buildings and overpasses continuously block GNSS signals. UM982 also features high reliability. In an age of intelligence where unmanned machines are ubiquitous and the environment is full of complex signals, how to suppress electromagnetic interference and ensure the security of machine operation becomes a big problem. With regard to that, UM982 is equipped with anti-jamming and jamming detection function, which can detect and output the jamming strength and help the control algorithm make judgments. The module also has digital signature function to ensure the security of data transmission. All of this make it an ideal choice for safety-critical applications. In addition to the aforementioned features, UM982 also aims at reducing the time to first fix. It uses the GNSS service provided by TruePoint, receiving assisted data such as ephemeris, almanac, ionosphere parameters, UTC corrections, etc. through wireless network or internet. And after using GNSS, the cold start TTFF of single point positioning can be reduced to less than 6 seconds, and that of RTK reduced to less than 10 seconds. Compared to our last generation products, UM982 supports hot start to accelerate the TTFF. When the V backup pin is connected to an external power supply, if the main power of the module is cut off, V backup will provide power to the RTC and relevant registers. At that time, hot start is available, and the requirement for the supply voltage of V backup is 2 volts to 3.6 volts. The TTFF of single point positioning under hot start is reduced to less than 4 seconds. There are some accessories sold together with the module, including the evaluation board, the evaluation kit named UniKit, which supports all Unicore products and supports 4G communication, entry protocol, and has data storage function. There's also an evaluation software called UPrecise. It's a visualized software and provides graphical user interface to help you easily set the configurations, display the positioning information, satellite systems, NMEA messages, etc. To explore more functions, you can contact us and download this software. Having talked so much about the excellent performance of UM982, We're glad to announce that in May this year, Unicore reached cooperation with NVIDIA. Based on the powerful AI computing and a multi-source fusion platform, UM982 is empowering the development of autonomous machines. We also provide mature SDK for users, and the platform is adapted to different versions of ROS and can provide accurate spatial temporal information. That's all for today's presentation, and if you want to learn more about our products, you can visit our website, call the sales hotline, or you can also send us an email, and we're ready to answer your questions. Thanks for watching. I'll see you next time. Bye.